Hey guys, welcome to Pepcoding. So today we are going to discuss a question reductant connection 2. Okay, so I hope you have already seen for reductant connection 1. If you haven't, then please go and watch because it would be directly connecting here. So in reductant connection 1, I was having a case of cycle. Okay, I was having this kind of case. Okay, this was my case, but here I can have more cases. For example, like 1, 2, 3, 4, 5, and say 6. This was my case, and suppose that 3 is also connected to 6, and the order of my input is 1 2 1 3 2 4 2 5 2 6 3 6. This was my order, suppose. So guys, here we can see that 6 has 2 parents, and this is now a graph. It was earlier a tree, but no one can has 2 parents, so it is graph. So if it has 2 parents, then how we would handle? It's not a cycle. See, it ends here, this ends here. It's not a cycle. So this is my case 1. Case 1. This is case 2. So let's see. So guys, earlier what I was doing was in degree. I'll do the similar thing, just there would be a difference. First of all, let's see how many input I have. So total 1 2 3 4 5 6. I have 6 inputs. So let's do the indexing. Till 6 0 1 2 3 4 5 6. So guys, here what I'll do is I'll come to I'll come to first 1 2, then initially first I'll mark all of them -1. Earlier it was 0, now it would be -1. Mark them -1. Come to 1 2, then at 2 it is due to edge number 0. So I'll update here 0. Then 1 3. At 3 it is due to edge number 1, so update it. 2 4 4 is due to edge number 2, update it. 5 is due to edge number 2. 6 is due to edge number 5 is due to edge number 3. 1 2 3. 6 is due to edge number 4, and then 6 is again due to edge number 5. When I come here, I check that it is already there. 4 is already present, so the value is not -1. So this means its degree is more than 0. So its degree must be 1 because it has already been modified. So now I also have that which was the first edge due to which the problem was created, and which is the second edge. So edge number 5 is my answer. But guys, wait. Here is a catch. In case 2, we all know how to do. Just detect its cycle and our work is done. It's similar to reductant when let's see case 3. Case 3 is a typical case. So suppose I have 1, 2, 3, 4, 5, and then back here. So guys, if you see that it is similar to first case, 2 has 2 parents. But suppose my input is in this order. Okay. Now what will happen? 0, 1, 2, 3, 4, 5. First, at second index it would be 1. Third index it would be, sorry, it would be 0th. Third index 1. then at 4th index it would be 2, 4, 5, at 5th index it would be 3, and then it would be 4 again at 2nd index, but it is not -1, so I'll have to give my answer 5 2. But what if my input was like this? Suppose my input was 5 2 and then 1 2. Then what would be my answer? So at 3rd I would be updating 0. Then at 4th I would be updating 1. At 5 I would be updating 2. At 2 I would be updating 3. But now when 1 2 comes, I check there is already value. It's not -1, so I need to return 1 2 according to my logic that we have discussed in previous case number 1. But what happens if I remove this? First of all, I lost everything, and it's still a cyclic, so there is a problem. I know only one problematic edge would be there, but here it's still a cyclic and my answer fails. So my answer must be 5 2 only. I'll have to remove this. So there can be only 2 possible answers. If there are 3, then it's impossible because that can't be my answer. Okay. In this case, there can only be 2 possible answers because whenever I would be getting wrong answer, first answer would be already updated, second answer I would be getting right now. So if I remove 5 2, then it's a proper tree. See, 1 is connected to 2, 2, 3, 3 to 4, 4 to 5, and it is connected to nothing. So guys, how will I say that which output I should return, 5 2 or 1 2? So it's a simple case. I'll just check that which one is creating the problem. Since 1 2 is in last, so I would blacklist them. Blacklist 1, blacklist 2. So since 1 2 has higher priority because it is coming at the end, so I would put it what is the index, 0 1 2 3 4, fourth edge, and fourth edge in blacklist 1 and third edge in blacklist 2 because fourth edge has higher priority because it is coming later on in the input. So what I'll do, I'll simply check for I'll run a for loop in union function. What my union functions do in DSU, my union function just tell me that which edge is problematic edge. Sorry, that if it has a cycle or not, my bad, if it has a cycle or not. So I'll simply check that is my cycle due to 1 2 or is it due to 5 2. Okay, so obviously BL2 would come first, so I'll run a for loop in all the edges. Then when BL2 would come, I'll check if it is my answer. If it is creating the problem, I'll simply return, and after running the complete for loop, because if I am removing 1 2, then my answer won't be affected. It would still have a cycle. So in that case, I won't return 1 2. The for loop would end. Okay, if suppose my BL1 should be the answer, in that case, for this 5 2, it would return false. Okay, so after the for loop, I'll simply return my edge of BL1. So I hope I am clear here. Now I'll simply code the problem and solve it for you. So let's just get it done. So basically, first of all, let's get the size of my edges because I would be using it many times. So why not get the size right here? So now create a vector in degree. Okay, it's of type int. In type in degree, size would be n plus 1 and its value would be -1. Now what? Now I'll simply make two variables, blacklist1 -1, blacklist2 -1. Now I'll simply make my parents array and wo vector parent and ranker. I'll resize them, they are already made. So ranker dot resize n +1 comma. Good, then that's it. Parent. Now fill the parent and ranker. So for int I0, I less than, I would be from 1 because I need to fill it completely. I plus plus parent I equals I, ranker I equals 1. Okay, one more thing. I have not taken my BL1 and BL2. I have just initialized them but not found. So the in degree part is remaining. For int I0, I less than n, I plus plus vector int edge equals edges of I, int u equals edge of 0, v equals edge of 1. I'll simply find if in degree of v is equal to -1, then in degree of v is equal to I, else BL1 equal to I and BL2 would be equal to in degree of v. By the way, it was not at all necessary to take u, but still, no matter. Okay, yeah, now I have BL1 and BL2. Updated the ranker. Now for int I equals 0, I less than n, I plus plus. Now what I have to do is I need to check which one is my correct answer, BL1 or BL2. I know BL1 and BL2 are potential answers, but which one is correct? So for that, if I is equal to BL1, in that case I'll simply continue, because if my BL2 is not the answer, at the end of the for loop I would be printing BL1. Okay, so in else part, what I'll do, I'll make a bool flag and call union. Union is a keyword, so I would be using union underscore, pass my u and v. Let me just define u and v first. Int u equals edge of 0, edge of 1 is v, and what is my edge? It's a vector of type int, its name is edge, and its edges I. Okay, now what? If my flag is true, so if my flag is true, in that case I'll check if BL1 is still -1, that is I don't have, then I'll simply return the edge. In that case, this is the case 2 that we have discussed. Okay, else return edges of BL2, and if BL2 is not the answer, that only means that my answer is BL1. Now I have called the union function. Let me make the union function. It's of type bool. It will have two variables, x and y. This is nothing new. We have already done this in DSU. So now what? So int leader of x is, let me call find x. I'll make function find, and leader of y, I'll get it from the find function. This will give me the leader. Now what? So if they both are equal, I'll return true, that is the cycle is present. Else I need to update the leader and the rank. So if parent of Lx, sorry, if rank of Lx, my bad, if Lx has higher rank than Ly, so parent of Ly is equals Lx. Okay, and copy this function. Else if rank of Lx is less than Ly, then leader of Lx would be Ly. Else you could make anyone the leader. I am making Ly. So parent of Lx equals Ly, and parent of rank of Ly would be incremented. So rank of Ly is updated, and since there is no cycle, so I will return false after updating all the things. Now I need to make my find function. So it is of type int. It has an argument of integer. So if x is equal to parent of x, then I don't need to work anything, simply return the x. Else I'll make a temporary variable that is equal to find of parent of x, and parent of x is updated, then and simply return temp. Okay, this looks fine. Okay, this seems fine to me. Let's try running. Some error in line 17. Let's check. Okay, return true. Let's run the code. Okay, it's accepted. Let's submit it. So guys, I hope you understood the concept and the code was clear to you. So please like, share and comment to the video and subscribe to Pepcoding. Thanks for watching.